Okay, now I will be going over question 11. So the important concept in question 11 is energy. So when I drop something on Earth's surface, let's say I'm in a tree and I drop like a ball down from the tree, the total energy will be the gravitational potential energy plus the amount of kinetic energy. So first let's define those terms. So gravitational potential energy is equal to mg times h. So m times g times h. So m is the mass of the object I'm dropping, g is the gravity, and in this case, or whenever we are on Earth, it will always be 9.81 on Earth's surface, and then h is the height from which I am dropping that object. And then the other part is the kinetic energy. So kinetic energy, which I'm going to represent as KE, is equal to 1/2 mv squared. So the m is the mass of the object, and v is the velocity which is being thrown. So when I drop an object on Earth's surface, at the top it will have maximum gravitational potential energy. And since at the top there's no velocity because I haven't dropped it yet, this will be 0. So at the top it's just mgh and it's at its maximum because it's at a maximum height. And then as I drop it, the height will decrease, and so mgh will decrease, and 1/2 mv squared kinetic energy will increase. So that is the principle that I am primarily using in this problem. Okay, so now I will read the problem. A 2-kilogram object is released from rest from a height of 3 meters above Earth's surface. How much kinetic energy does the object have when it reaches a height of 1 meter? Okay, so first, to solve this problem, we're going to figure out how much energy or how much gravitational potential energy it has at the top at 3 meters. And so then we have the total energy, and then we can plug that in to find the amount of kinetic energy at 1 meter. Okay, so first, remember total energy is kinetic energy plus gravitational potential energy. So the total, and this is at the top, so I'll just label that there, total energy is equal to mgh plus 1/2 mv squared. Remember, we haven't dropped it, so this is 0. Then the total energy at the top is going to be the mass, 2 kilograms, times 9.81, times the height, 3 meters, because that's at the top. Okay, so if we do that, we get total is equal to 60, and I already did the math. Okay, so 60 joules. So that's the total amount of energy at the top at 3 meters, the height we're dropping it from. Okay, so now I'm going to use that to find the amount of kinetic energy the object has at 1 meter. So I'm going to plug in 60 right here. Here, I'll just make a separate box, make it more clear. 60, so that's the total at the top. And then mgh plus kinetic energy. Okay, so now I'm going to plug everything in. mgh, remember 2. I'm just going to round this up to 10, make it more easier. And then at 1 meter plus the kinetic energy. Okay, so if we do that math, it's going to be 60 equals 20. 2 times 10 times 1 is 20 plus KE. Then if I subtract 20 from both sides, I get 40 joules equals KE. So that is the total amount of kinetic energy at 1 meter above what we are dropping it. So in conclusion, this problem showed important concepts of energy, that when you drop something from Earth's surface, it will have a certain amount of gravitational potential energy and kinetic energy. The total energy is mgh plus kinetic energy. And at the top, it will have maximum potential energy, and then as it drops, the potential energy will decrease while the kinetic energy will increase. And this helps us solve problems such as this one. Thank you.